The fundamental question that often arises in the realm of manufacturing is, how do we transform raw materials into usable products that we can buy, consume, or utilize in various ways? There are several traditional methods, each with its unique approach to material manipulation and product creation. One of the oldest and most common methods is subtractive manufacturing. This technique involves starting with a solid block of raw material and removing or carving away portions of it to create the desired product. This approach can be compared to sculpting a statue from a block of marble where the excess material is chipped away until the final form emerges. Examples of subtractive manufacturing include manual wood carving, computer numerical control or CNC machining, and laser cutting. These processes involve precise removal of material to achieve the required shape and dimensions. Another traditional manufacturing technique is forming, where a block of material undergoes changes in its dimensions when subjected to external forces. This method involves processes such as forging, stamping, and extrusion, where the material is shaped by applying compressive or tensile forces. Forming is highly efficient for producing parts with specific geometric features and mechanical properties. Casting is yet another well-established manufacturing method. In casting, the material, usually metal, is first melted into a liquid form. This molten material is then poured into a pre-made mold that contains a cavity shaped like the desired product. Once the material cools and solidifies, the mold is removed, leaving behind the final cast product. This method is particularly useful for creating complex shapes and large components with high precision. In contrast to these traditional methods, additive manufacturing, also known as 3D printing, represents a revolutionary approach to making things. Unlike subtractive manufacturing, where material is removed, additive manufacturing involves building up the product layer by layer from the ground up. Additive manufacturing encompasses a wide range of processes that create three-dimensional prototypes and structures from digital models. The foundation of additive manufacturing lies in the solid modeling component of computer-aided design. Computer-aided design software is used to create detailed 3D models of the parts to be manufactured. These models are then sliced into extremely thin cross-sectional layers, which the additive manufacturing machine reads and prints sequentially. This layer-by-layer approach allows for the creation of intricate and complex shapes that are challenging or impossible to achieve using conventional manufacturing methods. To better understand additive manufacturing, let's consider an analogy. Suppose we want to bake a batch of cupcakes. In an additive process, we start with an empty bowl and add ingredients one by one, mixing them until we get the finished batter. This is akin to the layer-by-layer approach of additive manufacturing. On the other hand, a subtractive process would involve starting with a large cake and cutting away portions of it until we achieve the desired cupcake shape. While both methods can produce the final product, the additive approach minimizes waste and allows for greater design flexibility. In 3D printing, the process begins with the creation of a digital design using CAD software. This design is then converted into a specific file format, such as Standard Tessellation Language or STL, which is compatible with 3D printers. The printer reads this file and constructs the object by depositing material layer by layer. Each layer is typically a few micrometers thick, allowing for high precision and detail in the final product. One of the most significant advantages of additive manufacturing is its sustainability. Traditional manufacturing methods often result in substantial material wastage due to the subtractive nature of the processes. In contrast, additive manufacturing uses only the material necessary to build the product, significantly reducing waste. Additionally, AM requires less post-processing and finishing work, further reducing material consumption and energy use. Another sustainable aspect of additive manufacturing is its potential for reusing and recycling materials. For instance, plastics used in 3D printing can often be recycled and reused, contributing to a circular economy. Furthermore, the technology's ability to produce parts with optimized geometries can lead to lighter and more efficient designs, reducing the overall material and energy consumption throughout the product's life cycle. The versatility of additive manufacturing extends beyond its environmental benefits. The technology enables the creation of complex and customized designs that would be difficult or impossible to achieve with traditional methods. This capability is particularly valuable in industries such as aerospace, healthcare, and automotive, where precision and customization are critical. For example, in the aerospace industry, additive manufacturing allows for the production of lightweight components with intricate internal structures that improve performance and reduce fuel consumption. In healthcare, 3D printing is used to create patient-specific implants and prosthetics tailored to the unique anatomical features of each individual. The automotive industry also benefits from AM by producing prototypes and end-use parts with complex geometries and enhanced performance characteristics. Numerical data further highlights the impact of additive manufacturing. The global market for 3D printing was valued at approximately $12.6 billion in 2020. And is expected to reach $62.79 billion by 2028, growing at a compound annual growth rate of 22.4%. This rapid growth underscores the increasing adoption and significance of additive manufacturing across various industries. Furthermore, studies have shown that additive manufacturing can reduce material wastage by up to 90% compared to traditional manufacturing methods. This reduction in waste not only contributes to sustainability but also translates to cost savings for manufacturers. In conclusion, additive manufacturing, or 3D printing, represents a transformative approach to creating products by building them up layer by layer from digital models. This technology offers numerous advantages, including reduced material waste, enhanced design flexibility, and the ability to produce complex and customized parts. As industries continue to embrace additive manufacturing, its potential for innovation and sustainability will only grow, paving the way for a more efficient and environmentally friendly future in manufacturing. Thank you for joining us on this journey through the world of additive manufacturing. Be sure to like, comment, and subscribe for more insights into cutting-edge technologies and their impact on our world.